This video is about section 6.1 normal probability distributions. So in this section we will introduce probability distribution with continuous random variables. So first let's look at some graphs about discrete random variables. These two graphs are from chapter 2 when we talk about frequency distribution. It's pretty obvious that both of these graphs are talking about discrete random variables because there are a limited number of random variable outcomes. So take the second graph, for example, you have 10 possible outcomes for x, right? Take the first one, for example, you have, I would say at most 160, a number that is less 160 number of different outcomes. So these two are dealing with discrete random variables. By the way, the shape with bell curve is called a normal distribution, and the shape with a straight line, a roughly straight line, is called uniform distribution, where the frequency of each value is about the same. We'll still talk about uniform distribution and normal distribution here, but the x we're dealing with, the random variable we're dealing with today, will be continuous random variables. Now let's look at this graph. It's a graph about the waiting time of a random passenger in an airport. And you can tell the waiting time could be any number between 0 minute to 5 minutes. And the probability of getting any value between 0 to 5 minutes will be the same. It's pretty obvious that we're talking about a continuous random variable here because the value of x, it's not able to count how many there are, and in other words, there's unlimited numbers of x values. And for this graph, for each x value, you get the same output. There's no y value here, but for each input, you get the same output, right? This is a uniform probability distribution, where the probability of getting every value is the same. Notice that the horizontal axis is the x-axis, and the vertical one is called p of x. Here is not the probability. Here, this value is the probability density. This is a density curve. So how do we use this probability density curve to find the probability? Well, here's how. The probability of a certain interval A is equal to the area below the curve in that interval A. So if the probability of a passenger's wait time is less than 1 minute, will be equal to the area below the curve in that interval. So the interval we're talking about is between 0 and 1, right? So the probability of getting a number that's between a minute that's between 0 and 1 is this area. So how do we find the area of a rectangle? Width times length, right? So here the width is 1 because this is 1, and the length is 0.2, right? So 1 times 0.2, here is 0.2. So the probability of a passenger having a wait time less than 1 minute will be 0.2. Another example. So what is the probability of a random passenger's wait time is between 2 and 4 minutes? Well, similarly, the probability of the wait time between 2 and 4 minutes corresponds to the area underneath the curve between 2 and 4, which is still, in this case, is width times length. Right? Width, here's 2. Length, 0.2, which is 0.4. So the probability of a random passenger has a wait time between 2 minutes and 4 minutes is 0.4. So you can probably tell the area underneath the whole curve will be 1, right? You can tell it. Here's 5 times 0.2, it's 1. So this is true for all density curves. The probability or the area below a probability density curve is 1. After talking about the uniform distribution, let's look at normal distribution, which is a bell curve shaped distribution. So this is a graph of a normal distribution for continuous random variable. The value in the middle is the mean, and the whole graph is bell-shaped and symmetric, and it will start low, and when it's around the mean it's high, and when it goes to higher values going back to low again. So this kind of shape is called bell-shaped or normal distribution. Similar to the previous density curve, the area underneath the whole curve will be equal to 1, which means the probability of getting every possible value of x is equal to 1. Also similar to earlier, if you want to know the probability of certain interval, let's say this value is a, this value is b, I want to know the probability of x is greater than a, less than b, all you have to do is find the area underneath the curve. We usually do not find this kind of area by hand. We'll either use a table or we will use technology. So first we'll study the simplest normal distribution. It's called standard normal distribution. For a standard normal distribution, your mean is equal to 0 and your standard deviation is equal to 1. What's so nice about this standard normal distribution is your x value, let's say here's your x value, which is 1.52, for example. That x value is the z-score of that value. So later in the chapter, when we talk about a normal distribution that is not a standard deviation, standard normal distribution, we would like to turn it into a standard normal distribution because it is so nice. The x value is the z-score. And you can see the area underneath the whole bell curve is equal to 1. In other words, the probability of all the possible outcomes is 1. Okay, so say we want to find the probability of a value with z-score or x value, they're the same, with z-score less than negative 2.13, for example. All right, so that probability corresponds to the area, to this area, right? Say this is negative 2.13, and this area is the probability of z less than 2.13. Okay, so we can use a chart. What chart are we talking about? In our textbook, there's A2 table. Which looks like this. When you're given a z-score, you can find the area to the left of that z-score, which is shown in the graph like this. What we're looking for is the probability of a z-score less than negative 2.13. So let's find the z-score of negative 2.1, and here's 3 right here, this value. Okay, so this value tells you the area to the left of the z-score of negative 2.13, which is 0.166. Sorry, 0.0166. Okay, so the answer here is 0.0166 because the area there is equal to the probability. Now let's look at this problem. I want to find the probability of x value or z that is greater than, let's say, 1.52. All right, so like I showed you earlier on the A2 chart, what's been given you, what will give you is the area to the left of the z-score. So if you find the value of 1.52 in the chart, what will give you is the area to the right. Sorry, to the left of that value, as shown here. But what you're looking for is the area to the right of 1.52. Right, so what we do is, knowing the whole area underneath the curve is 1. First you find this area, and whatever you get, you will use 1 to subtract that area, and what you get is the area we're looking for. So going to the chart, looking for the z-score of 1.52. So 1.52. Okay, here we find it. The z-score, the area to the left of the z-score 1.52 is 0.9357. This means this orange part, this area is 0.9357. 357. Okay, that's this orange part. But what we're looking for is this red part. Well, we will find it by using 1 to subtract that, 0.9357. And the answer is 0.0643. Okay, the next problem, let's find the probability of a random value that is with x value, or in our case, since it's a standard normal distribution, a z-score between, let's say, negative 1.05 and 2.46. All right, so we already know in the chart, what's given you is the area to the left of the given z-score. So what you can find is basically negative, if this is negative 1.05, you can find this area in the chart, and you can find, this is 2.46, because the number right in the middle is 0, right? You can find this area. But what we're looking for, if I draw a chart here, if this is negative 1.05 and this is 2.46, what we're looking for is this area. So what we're going to do is find this area first, the area to the left of 2.46. to subtract the area to the left of negative 1.05. Whatever we get, the difference we get will be the area in the middle. So if I write it down using probability, it will be P of, we will get the x less than 2.46. Find that part first, which is this part, minus the probability of x is less than negative 1.05. Okay, so going to the chart, first the area to the left of the z-score of 2.46. So 2.46 is all the way here. So 9931, 0.9931. So that's 0.9931. And then now we are looking for the area to the left of negative 1.05. So negative 1.05 is right here. So 0.1469. Okay, so we found earlier that this is 0.9931 minus this part is 0.1469, and the answer is 0.8462. Okay, so this is how you find the probability of a certain interval using a table, a z-score table. You can use other technologies, kind of like TI-84, TI-83, Statcrunch. Here I will show how to find those probabilities using Statcrunch. Okay, in the right side of the screen is the Statcrunch. So to find the same values, the same probabilities, you can go to Stat, Calculators, and here you go to Normal, because we're talking about the normal distribution. All right, so since right here we're talking about a standard normal distribution where the mean is 0 and standard deviation is 1, you don't have to change these two values. Just leave them as 0 and 1. Okay, so the first problem, the probability of x greater than 1.52. So you will put greater than or equal to, here we're talking about the same case. Since this is a continuous random variable of one value will not change your answer at all. So greater than or equal to 1.52. So 1.52, there you go. 1.52, compute, and you can tell here shows the area with x value greater than 1.52 is 0.0642, well 3 if you round it up, same value. Okay, now let's look at, okay, I'm looking at the second problem. Now let's look at the first problem, this one. P of z-score less than negative 2.13. Let's use Statcrunch to find that value. So similarly, mean is 0, standard deviation is 1. X here is less than, here is negative 2.13. You can find the probability being 0.016. If you round it up, it will be 6. Right. Okay, last one. How do we find the interval between two values? Here you will click here, between. So on the left end, you put negative, our case is 1.05. On the right side is 2.46. 2.46, compute, you have 0.846, you round up 8462. Okay, so what we have done so far is giving you a z-score. You find the area, or we can say probability, related to that z-score. What if we're given an area and we want to find the corresponding z-score? Right, so let's look at this example. The graph here is a standard normal distribution with mu equal to 0 and sigma equal to 1. So mean is 0, standard deviation is 1. This is standard normal distribution. And we know this green part is 0.8907. So we're given the area, or we're given the probability. We want to know this z-score. Okay, so still I'm going to show two ways. One way is to use the A2 table. One way is to use the Statcrunch. Okay, so to use the A2 table, we know what's shown on the A2 table is the area to the left of the z-score, right? Okay, here, yeah, we know the area to the left of the z-score is 0.8907. So what we're going to do is find the area of 0.8907 and then find the corresponding z-score. So going to the table, okay, the area we're looking for is 0.8907. So 8907, let's see. 8907, there it is. Okay, so the 8907, yeah, I lost it. There it is. Okay, so the z-score, the corresponding z-score to this area is 1.23. 1.23. Okay, so the answer here, the z-score is 1.23. So that the area to the left of it is 0.8907. Now let's look at the B part. B part, what's given you is the area to the right of this z-score. But we know on the A2 table, what you're given is the area to the left. So what you need to do is find the area to the left of this z-score, which is 1 minus 0.2061. So I get 0.7939. So now we will go to the A2 table and find the area of 0.7939. So 0.7939, 7939, right here. Okay, the z-score, the corresponding z-score is 0.82. So go back to the problem. The answer here is 0.82. How do we use Statcrunch to solve this problem? We'll go to Statcrunch, go to Stat, Calculators, Normal. Okay, mean and standard deviation are 0 and 1. And first, the A part is Z. We know the area, right? So we should put an input here. This area is 8907, so 0.8907, and the area is to the left. That means less than the z-score we're looking for. So compute. What's given here, 1.23, blah, 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 is the z-score we're looking for. Okay, next, let's look at this problem B. All right, what we're given is the area of 0.2061. So I will put 0.2061, and the area is to the right of the z-score, so greater than. So what you get is 0.82. All right, hopefully you find this video helpful, and I will see you next time.